Okay, so as we were told earlier, when the LP was introduced to us, we were told that there were three methods or three ways we could solve a linear programming problem. One was the graphical method, which we've done. Then we have the simplex method, where you do hand computations of, to come out with your optimal solution. And then the last one is the Excel or the computer aided solution one. So far, I believe we are done with the graphical method. And so when you are given any LP problem and you are asked to use the graphical method to solve it, I believe that all of us here can solve it, or at least we have an idea how to go about it. And again, we've done the sensitivity, right? Have we done sensitivity analysis?
Yes. Yes.
So again, if we are asked to use the Excel to solve it, we also know how to go about it. But at the MPhil level, you need to know what goes on behind the machine, what goes on behind the computer. You remember that when you are going to use the solver to solve an LP problem, that you select the simplex method. Please, do you all remember?
Yes.
Yes.
You select the simplex. So the solver uses what we are going to do today. But of course, because it's a computer, it will use some few seconds to do it for you and give you your answer. But today we are going to learn how that happens, the hand computation. So we call it the simplex method. It is simple and it is complex. It is complex though, but if you follow the steps, you would realize that this is one of the easiest questions you can tackle in an exam. Okay, it involves lots of calculations, so we should all get our calculators by our side. I really wish we did this in class, but I believe we can still nail it here. Okay. So the simplex method is actually an iterative algorithm. It deals with iteration, repeating some systematic solution procedure. Okay, that keeps you keep repeating the same procedure until an optimal solution is found. So it's just a step-by-step approach in computing or coming up with the solution that you need, the optimal solution that is in the LP problem. It was developed by George Danzig in 1946. I'll leave the history for you to go and read, But then you see that when you take the graphical solution, you cannot use the graph to solve any problem that has more than two decision variables. I believe we are all aware. Yes, and so the simplex method helps us to go beyond that. And like I said, it is based on that the solver was also developed to aid us. Okay, so what the simplex method does is that you will realize that with the graphical, after you have drawn your graph, drawn your constraints, and you have the feasible solution area, we all know that the feasible solution area is bounded by some points. And so at the end of the day, we calculate the Z value at points A, point B, point C, point D, and then we find out which of the points is giving us the maximum profit or the minimum cost that we're looking out for. It is the same way the simplex method also works. Like I said, it is an iteration. So at each iteration, the feasible solution or the Z value and the optimal solution for each of those points are examined, or like you realize that after each iteration, you will come to see that, okay, this solution was actually for this point, and that solution was actually for this point. What it does is that when it is done, when it takes you through the process and it gets to the point that yields the optimal solution, it ends there. And then we will take an example so you would better understand all those things that I'm saying. Okay. So it is a step-by-step approach, like I said, that is used to solve real-life problems involving more than two decision variables. Let's look at the steps. Now we know how an LP problem looks like. We all remember at least our Fan-Milghana Limited problem, okay? The first thing you do in an exam, so when you are given such a question that you should solve a particular problem using the Simplex Method procedure, the first thing you do is to convert the problem to the standard form. Please, we all know how to convert into the standard form, right?
Yes.
Okay, so that is the first thing you do when you are asked to solve any problem with the Simplex method. You convert it into the standard form. And then the next thing is to form an initial Tableau. It is a table. We're going to have a look at it and then you see it's very simple. Then you obtain a new Tableau. So that is the process. We're going to go through it. Okay. But then there is a process of obtaining this new Tableau or forming new iterations until the final solution is derived. Okay, so we'll go through this process. But for us to follow the steps, let's take an example. Okay, let's take an example and then it will take us through this process. Because we are all familiar with the Fan-Milghana Limited problem, we would be using that. So a moment, let me share our high screen. Who can give me the LP problem for the fan milk? The fan milk, we were maximizing, right?
Yes.
A volunteer, please, a volunteer. Was it
40x1
40x1
plus 50x2?
50x2.
Subject to
Okay.
1x1 plus 2x2.
2x2. Gosh.
Less than or
equal
equal
to.
to.
Is it 40?
Yeah.
40, yeah. And then 4x2, 4x1
Yeah.
plus, is it 3x2, right?
3x2
3x2,
less or equal to 120 gallons.
120 gallons. All right, then we bring our non-negativity constraints, x1, x2, that's greater or equal to 0. Thank you. So you've been given this problem in an exams and you are asked to solve the problem using the Simplex method. Like I said, the first thing is to convert this into its standard form. So as we already know, we won't waste time here. We know with the standard form, you introduce the slacks. And so we'll have this objective function with some slacks introduced. And we said that we introduce the number of slacks based on the number of constraints that we have. So S1 for the first constraint, and then S2 for the second constraint. And they are carrying zeros in the objective function because they actually contribute nothing to the objective function value. Okay, so you come and do the same. You come and add them to the constraints. So we're going to have plus S1 here, and then plus S2 here. And of course, our signs will now change from less than or equal to equal to signs. Please, are we all good up to this point?
Yes, please.
Okay, who said yes, please? Is it Christabel? Miriam?
Yeah.
Okay, Miriam is okay up to this point. Any question from anybody? Any
No question.
Okay, thank you.
Please, the first constraint, it's supposed to be 1x1 plus 2x2.
The first constraint, okay, yes, that's true. That's 2x2. Okay, so we are done with the first step. Please, because this is a whiteboard and we are limited, any step that we do, please try and get the step down, write it down, so that as we move on, you move on with us, okay? So I believe that by now you have the standard form of your problem written. Okay, so let's go back to our slide and see our next step to take. It says that we should form initial tableau. Now, what is the initial tableau? Because of space, I used an Excel, or I drew the tableau in an Excel. So let's take our time to understand this tableau and then what is supposed to go into the tableau. Please, do you see an Excel sheet opened?
No, please. No, please.
Okay, so I drew this. If it was in the class, I'll have to draw this on the board. So I came up with this. Okay, so this is the initial tableau. It has the iteration column. It has the basic variable where we list the variables in our the LP. I mean the standard form of the LP. So you realize that in the standard form we have the X1 values, and then we have X2, we have S1, which are the slugs, S1 and S2, and then we have the Z. Now, how do we convert, or how do we get the values from the standard form that we have to fill this table? So let's look at the standard form that we wrote. What do we do before we come to the table? What do we do before we come to the table? This standard form, before we can use this information here, or the coefficients here, to fill our table, you have to always equate the objective function to 0. Please remember that point. You always equate the objective function to 0. You always equate the objective function to 0. The constraints remain untouched, which means that our Z function is now going to be Z. Because we are equating all this to 0, we have to bring all this to the left-hand side, and then we have equal to 0. So we're going to have Z max is equal to, or Z minus 40x1, okay, minus 50x2, minus 0s1, minus 0s2. So we would have the right-hand side of the objective function to be 0. Please, do we have this? Do we have this?
Yes, we do.
So these are the values that we are going to use to fill our table. So you realize that we have the Z, we have the X1 with its coefficient, we have X2, S1, S2, and then the right-hand side. And then we have the same for the constraints. We have the left-hand side, and then some values at the right-hand side. So you come to your initial table. This is the initial table that has the very basic information of your standardized form of your LP. So you realize that When you go to the table, when you come to your Excel, you realize that you have X1, X2, S1 and S2. So you're going to put the values or the coefficients of those ones on each of the rows. So when you take the zero, this row, the S1 value there is what?
Minus 40.
Minus 40. Thank you. The S2 value is
minus 50.
50. S1 is 0 and S2 is 0. And we equated it to 0. So our right-hand side is also 0. Are we okay with that? So that is how you get the values for your 0. Then we come to the S1 and the S2. This S1 and S2 are representing the constraints, which means that in a case you are given 3 or more constraints, i.e. you have more than 2 X's, slacks, then you're going to have, let's say S3, you're going to have S4 like that in an example. Okay, so in our example, we have 2. So we're going to the constraints now and pick the values of these variables to fill our form. So for the first constraint, what is the value of X1?
1x1. It's 1x1.
1. Thank you. And X2 is 2, right?
2.
Okay. S1, what's the value there?
1.
Okay. And S2?
0.
Thank you. So we come to the second constraint. No, let's do the right-hand side. The right-hand side was 40, right? That is for the first constraint. Now when we come to the second constraint, we have X1 value to be 4, X2 is 3, S1 will be 0, and S2 is 1, and the right-hand side is 120. Please, any question up to this point? Any question up to this point, please?
Please, I don't understand why the first constraint, the S1 is 1 and the S2 is 0.
Okay, so when you look at the equation that we wrote on our whiteboard, okay, you realize that when you take the constraint here, please, do you see my whiteboard?
Yes, please.
Yeah, please.
S1, you see the first constraint, when you change it to the standard form, you have 1x1, you have 2x2, you have S1. So it's assumed that it is 1S1, right?
Okay.
But there is no S2 here. There is no S2 on this line, this row. That is why S2 is having a value of 0 here on our table. And then the same way you come to the second constraint, there is no S1. And so S1 here would have a value of 0. And S2 will have a value of 1. Please, are you okay now? Or you
Yes.
still don't get it?
I get.
Okay. Okay, I believe you see the Excel now. You see the Excel?
Yes.
Okay, so let's try and identify the things here. Now we know the values, we've been able to fill the values, okay? But to be able to do the pivoting or to be able to continue with our iteration and then get our solutions, we need to know what each of these items are actually representing. So when you take the Tableau, the Simplex Method table like this, there are some basic things that you need to know. Okay, we have something called pivot column. We have something called pivot row. We have entry variables. Yes.
Please, as we are following, are we to also put this in an Excel? This one is going to be handwritten.
This is not in a, you're going to write this actually. You're going to draw it in an
Okay.
exams like with ruler and pen or pencil. But because we are doing it on Zoom and our whiteboard isn't big enough, I want us to have the table here. Then when we go and do our calculations, we'll come and fill the table here.
It's fine.
Get it? Okay. So like I was saying earlier, we have some basic features of this table that we need to understand to help us with the operation, okay? So we have something called pivot column. We all know what columns are. These are all the columns in this table. We have pivot column. We will come to understand what a pivot column is. We have pivot rows, okay? Then we have entry variables, we have leaving variables, we have something called pivot elements. Okay, so this is our initial table. What is this table giving us? It is giving us the constraints and then the objective coefficients, and it is also giving us the right-hand side values of the table. Now, how do we go ahead with our solution? There are steps to follow. The first step is to identify our pivot row, our pivot column. What is this pivot column? It is the column with the biggest negative Z value. It is the column with the biggest negative Z value. So who can identify our pivot row? Yes.
Hello, Dinah.
Yes, boss.
I think you went off. We're not hearing you. I don't know whether it's my internet. I wasn't hearing you when you started with it.
Oh, really? Really? Can you hear me now?
Yes, I can hear you.
Okay, what about the others? Can you hear me, please?
Loud and clear.
Oh, okay.
Please, I can hear you. Thank you.
Okay, thank you. So I was saying, okay, so now everybody can hear me. What I was saying is that the first thing is to identify our pivot column. And I said the pivot column is the column with the biggest negative Z value. So who can then tell us which of these columns is our pivot column? Who can tell us? X2, thank you. So X2 is our pivot column. X2 is our pivot column. So always note how to identify your pivot column. You look at the Z values, and then you look at which of the values has the biggest negative value. And that is negative 50 in our case. So S2 is there. Now, once you identify the pivot column, you have to now identify your pivot row. That is the next thing to do, your pivot row. So one of these rows would be our pivot row, either S1 row or S2 row. How do we also identify that? Before you can do that, you need to find this column, which we call the ratio. The ratio. The ratio is the left-hand side value divided by the corresponding pivot column value. Please, did we get that?
No,
Sorry,
I didn't get that.
Sorry,
Okay.
I didn't get that, please.
Okay, so I was
Madam
saying
Dinah.
that, hello.
I
So
didn't
was
get the
saying-
last part, please.
Okay, so I was saying that the next thing is to identify our pivot row. Okay, you can't just look at it like this and guess. We need to find some ratios here. We need to find some ratios here, and then based on that ratio, we will select our pivot row. Okay, and I was saying that the ratio here is equal to the right-hand side value, which are the values here. The right-hand side value divided by the its corresponding pivot column value. So let's say if we take this row, it is going to be 40 here divided by 2. If we take the next row, it is going to be 120 here divided by 3. Please, do we get it? So the first row, we're going to have 40, divided by 2, and that will be equal to 20, right? Then the second part, we're going to have 120 divided by 3, and that will be equal to, what? 40. That's 40, right?
Yeah.
Okay. So after you compute the rows, the ratios, okay, for each of the rows, the next thing is to identify the row with the smallest positive value. And that row will become your pivot row. So who would give us the row now? Who will give us the row? We are saying that the row with the smallest positive value is our row. So S1 is the row. So this row here becomes...
Question, please.
Yes, I'm listening, please.
Okay, so it's the row, when you're looking at the row, you're talking about the ratios on the row with the smallest positive value, right?
Yes. No, so you are concentrating on the ratio value, the values we got here, 20 and 40. The 20, see, we did some ratios here, okay? And we derived 20 for S1 and 40 for S2. So you always pick the row that has the smallest ratio value, the smallest positive ratio value. Hey, my internet. Am I gone off again? Can you hear me?
We can hear you.
Okay, okay. It is giving me signals here, so I thought I was gone. Yes. Any question, please?
Yes, I want to know why you didn't calculate the ratio for the Z column.
Okay, so we do not calculate the ratio for the Z columns because the concentration is on the slacks, the X's. And you come to understand why soon. Okay, that is where we need to select either of these rows. And that is why we did the ratio computation here to help us identify the pivot row. Please, can we go on? So that is what a pivot row is. Now, where the pivot column and the pivot row meets, in our case here, becomes the value that becomes our pivot element. Please note this ones down because several questions, especially in IA, can be asked around these figures. Okay, those names. So where the intersection, so that you can see that the pivot element is the coefficient or the value at the intersection between the pivot column and the pivot row. I believe we all get it. Okay. So in our case, we'll say that our pivot element is 2. Our pivot element is 2. Our pivot element is 2. Please, any question up to this point? Any question up to this point? Any question up to this point? Simplex method is very simple, but it can be very confusing and complex. That is why I'm taking my time and making sure that we all follow me through it, so that by the time we get to the end, we know we are done with it. Okay, so now we know our pivot row we know our pivot column, and then we know our pivot elements. Now the X2 here becomes our leaving variable, the entering variable, and then the leaving variable. So you ask, what are they? The next iteration that we're going to have, the value that the basic variable on the pivot column will now leave, or it would leave this column and enter the left-hand side here. So this is our first iteration. Now, if we go to the second iteration, I'm just going to copy this and put it here. Okay, we have to change all those values. When we come to iteration 1, okay, the previous basic variable that was on the column, the pivot column, will now move from the column or where it is to enter or replace the S1 value here. So this becomes the entering variable and S1 becomes the leaving variable. So in an exams, your second iteration table or iteration 1, we say the iteration 1 because we believe that the first one, you didn't really do any work there. It was the initial or the basic variables, that the values that were given that you used to draw this table. But the first iteration is actually where you're going to start with the computations. Okay, so we call it the iteration 1. At iteration 1, the value or the basic variable here, which is X2, which was on the column, the pivot column, will now come to replace the S1 value on the pivot row. So you'll realize that we will no longer have S1 here, but we're going to have X2. And we're going to have X2, so we're going to have Z, X2, and then S2, which means that S1 is our leaving variable. It is out of the context now. Why are we trying to do this? We're trying to do this because if you look at this side, this is our solution side. This is where we're going to find the solution, the optimal solution and the Z value at the end of the day. So we're going to have X1 and X2 values or solutions here. So this is a way of bringing the X1 into these rows and the X2s into these rows. But like we did earlier, this was the process to identify which of the X's here should come and replace which of the S's here. It may be complex, yes, but just follow. Hello.
I'm confused.
Okay. So, okay, let's do this. Let's go back to the slide, okay? And then we will come back here. Let's go back to the slide. Okay, so this is what we were doing, okay? The first point, we converted it to the standard form. Then we formed our initial table. This was the initial problem that was given. And then we changed it to our standard form and equated the Z function to 0, like we have done. Well, this is what we did on the whiteboard, okay? And then we transferred that information into this initial table, which we call the basic, the initial simplex Tableau. Basically, that's the initial table. So that is at iteration 0. Okay, now when we did this solution, when we did this table on our Excel sheet, we realized that this is the basic information that was actually given to us per the LP problem or the standardized problem that we had. Okay, so this right-hand side here always gives us the feasible solution. or the optimal solution, this right-hand side. So it is selecting all, but I'm only referring to this right-hand side column, this column, okay. Now, after we did this column, we realized that it is the basic. We haven't achieved any optimal solution there. And so we have to move on to the next iteration. Now, in moving on to the next iteration, you have to find the pivot column, find your pivot row, okay, and identify your key element or your pivot element. Those things that we identified are going to now help us to draw or to compute our next table. So we're going to have new values all together for the next table. When we draw it, you see how it would look like. Okay, but we will need the pivot column that we identified. We will need the pivot row that we identified, and we will need the key or the pivot elements that we identified to help us compute the values in the next set or the next iteration. Please, are you getting it?
Yes.
Okay, and then another thing, let's also put this down. Another thing that will help you know that a particular iteration isn't giving you the optimal solution, okay, is the fact that the Z value would have negative values. Of course, there is no way iteration 0 will ever give you your optimal solution and you stop. But one thing that will help you know that, oh, I have reached optimality or I have gained my solution. Therefore, the values I am having under this right-hand side are actually the optimal solution. Is when this Z value row, the Z value row has non-negative values. The Z value row, when it has non-negative values. So here we see that there are negative values here. And so we know that this initial tableau has not given us our optimal solution. So we are moving on to the next tableau. And like I said, the pivot column, the pivot row, and the pivot elements are going to help us to now compute the next table. Please, any further confusion?
Okay, so Dinah, if I get it right, does it mean that you keep doing the iteration until you get the optimal
Solution.
value of your optimal solution?
Exactly.
Okay.
You will keep
Okay.
doing. So sometimes you will do iteration 0. Iteration 0 is always like the initial. So there is no way you can get your solution there. It doesn't happen. Okay. So it is iteration 1, iteration 2. Sometimes you go iteration 3 before you find your solution. Sometimes at the second one, iteration 2, you can find your solution there. And like I said, one of the things that will let you know that, oh, this is my solution, it is when the Z value or this row has a non-negative value. Please, are you okay now?
Yeah, I am okay.
You're okay. Any other person with any confusion? Okay, silence means we are all okay. So now let's go to our Excel. Let's go to our Excel and continue with the next table. Okay, but before we go, let's go through the slides and then see how so this is what we did. You see, we have the entering variables, we have the pivot column, like the slides will be made available to you after the class. And so you'll be able to identify, this is what we talked about, identifying your row, the pivot row, the pivot column and all of that, okay. Now, how do we compute the values for the second table? The second table. So you realize that we now have a pivot column, we have a pivot row, and then we have the new rows that also has to be computed. We have the pivot column, we have the pivot row, and then we have the Z value row, we have the S2 row that we have to. So how do we get the values for the new pivot row, this row? At each iteration, that is the first row that you have to compute. So for instance, if S2 was the pivot row during this stage or at iteration 0, then S2 would have been computed first when we come to iteration 1. In our case, this row was our pivot row, and so we are going to compute that first. Okay, so how do we compute it? You do the current value, the current coefficient, divided by its corresponding, or divided by the key elements or the pivot elements for each of the values here. So we're going to have 1 divided by 2, and we'll put the answer here. We're going to have 2 divided by 2, we have the answer there. 1 divided by 2, we have the answer there. And then 0 divided by 2, we have the answer there. And 40 divided by 2, we have the answer here. So to find the new pivot row values, we divide the values or the coefficients by the pivot elements. That is how we find the pivots or the new values for the pivot row. So let's do it. So the first x1 value will be 1 divided by 2, which would give us 0.5, right? Then the next cell will be 2 divided by 2, so that will be 1. We'll have again 1 divided by 2, so 0.5. Then we have 0 divided by 2, which is 0, and 40 divided by 2, which will be 20. Please, do we all understand that to this point? Do we all understand up to this point? So at iteration 1, this becomes our new values for x2, our new coefficient for x2. Any question, please? Are we here?
Yes,
Yes, we are here.
It's fine.
It's fine, okay.
Yes, we are with you.
Okay, so now we have our new values. When you go to the slides, you realize that it gives you a formula for finding the other values. It gives you a formula for finding the other values, and you have to write this down. So this is how we found our new pivot row values. This was the current pivot row value divided by the pivot elements. That's what we just did. And we got these values for the new row at iteration 1. So we are done with this. Okay. Now there is a formula for finding the other values. So you see that the Z value row, and then the Z row, and then the S2 row are vacant now. We're going to fill them. This is how we are going to fill them. So please write this formula down. So the new row will be the current row value minus its corresponding column, pivot column coefficients times the new pivot row values that we have computed. Please get this formula down. And then we will take this formula to our Excel and do the computation there. Please, are you done with the formula? Can I move?
I'm done.
Okay. All right. So when we come here, we say that the formula you have written down simply means that pick the current value. For instance, we're going to start with the 0. Let's compute for the 0 first. Pick the current value, okay, minus its corresponding pivot column coefficient, this column. So when we take the 0, the coefficient on its pivot column is -50. Okay, and then we multiply that -50 by the new values that we have found, the new pivot row values. The new pivot row values. So we're going to have, let's go back to the board so that we do the calculations there. This switching isn't helping us. Okay, so let's use this. Please, are you seeing the slides or the Excel?
I'm seeing the
slides.
slide. Yes.
Okay, so when we take the new 0, you realize that on that row we have -40, -50, 0, 0, 0. And then we said that that's all this will represent the current row values. Okay, that's part of the equation. Then minus its corresponding column coefficient. Realize that when you take the pivot row, the pivot column, when you take the pivot column on the 0, the coefficient there is -50. And so you're going to multiply that -50 now by the new pivot row that we have found, the pivot row values that we have found. So this is how your equation will look like. So you have the current values in one bracket minus a bigger bracket. It's a bigger bracket because the -50 is going to multiply the values in this bracket. So we will do this open bracket first before we go ahead. Okay, so this is all that this equation is saying. So after you've written this, we now do open brackets. We multiply the -50 by each of the values in the bracket here. Okay, and that is where we got the -25, -50, -25, 0, and then -1000. Now, once we have opened this bracket, all you do is the current value minus its corresponding value in this bracket. And so you're going to have -40 minus -25, -50 minus -50, 0 minus -25, 0 minus 0, and then 0 minus -1000. Please, are we following?
Hello.
Yes.
Isana, so is it sigma? Is it summation of the and then summation of the pivot column coefficients times the new pivot row? I would want to understand, because so if it means a summation, then we open brackets on the right hand side, which then will be applied on all the variables in the bracket. So is it summation?
Summation of the left hand side or what? Because per the formula, okay, per the formula, we have this row, the current row value, okay. So let's say that for the first column, it was -40, right? And then you are multiplying that with, you are deducting the product of the corresponding pivot column coefficient. In this case, it was -50. Okay,
Yes.
-50. You're multiplying that -50 by the corresponding new row value that you found.
Yes.
You see, so here you realize that when you take this row, for instance, it is this bracket minus this bracket.
Okay.
But here you are seeing positive here, probably because of the negative.
Okay.
You know, -40 minus 25 is like -40 plus 25.
Okay.
So it's the same. Okay.
Okay, so it's like we are computing by position.
Yes, by position. You're not adding them at all.
Okay,
You
all
are
right.
so by the time you finish with this computation, you would have the values for all the cells on that row.
Okay.
So you realize that here we have -15, we have 0, we have 25, we have 0, and then we have 1,000. So we'll use that to now fill Excel. Okay, so you're going to have -15, we have 0, we have 25, 25, we have 0, and then 1,000. So this is how our Excel will now look like. So you realize that that one's computation has now given you the values for all the cells on that row. Please, do you see it now? So you're not adding them. You are computing
Okay.
for each of the cells. Then you use the same formula for the other row, which is the S2 row as well. So let's go back and then compute for the S2 row. Or who can even help me compute? I believe you have your calculator and your pen and pencils with you. So let's try and compute here. So when you take the S2 values, for instance, this cell, our current value is 4. So that will be 4 minus 3 times 0.5. And what would that
Please,
be?
we can't see.
Oh, are you seeing the Excel?
Yeah.
Yes, that's what I'm using. So we are computing for this row, the S2 row. Okay, and I'm saying that the same formula, I believe you wrote the formula down. The formula that we use to find the Z values. It is the same formula you will use to find this other value. The S2 row, the values for the S2 row. So I was saying that you have 4, 3, 0, and 1. Okay, so you're going to have 4, 3, 0, and 1. Minus so we're going to have 4, 3, 0, 4, 3, 0, and 1. Is that what we have?
Yes.
And then 120. Was it 120?
Yeah, 120.
120. So it will be this. Okay. It will be this minus the corresponding coefficient on the pivot column is what?
3.
3. So that 3 will now be multiplying the new 0, then the new pivot row values. So we have 0.5. We have, please call it out for me. 0.5 and what?
5, 0,
Okay.
0.5,
0.5. Okay.
0,
Are you sure? Because something is left out.
20. And
There was a 1 somewhere.
1.
Please give
wait,
me the right figure. So and say
0.5,
1.
1, 0.5,
Okay.
0, and 20.
Okay, so this is it. Okay, so this is how the equation is going to be. Okay, so you first of all open your bracket. So it's going to be 3 times 0.5, and that will be 1.5, right? Okay, comma 3 times 1 is 3, comma 3 times 0.5 is 1.5. 3 times 0 is 0. And then 3 times 20 will give us 60.
60.
Okay, so we have this, and then you maintain the same thing here. Please, in an exams, you go this step by step, because every step will yield some marks for you. Sometimes you might even get the answer wrong, but the steps will help you. So this is it. So we go ahead and now do each of the value here minus its corresponding value here. So we're going to have 4 minus 1.5, and that will give us 2.5, right? Comma, 3 minus 3 is 0. 0 minus 1.5, that's negative 1.5. 1 minus 0 is 1. 120 minus 60 is 60. Okay, so these are the values that we're going to use to fill our table. Please, have you written it down? I'm going to the Excel. Have you written it down? Hello?
Yes.
Okay. So we'll come here and now write 2.5. What's the next value?
0
Okay.
minus 1.5.
Okay.
1.
Okay.
60.
Okay. Okay. So now we are done with this iteration. Let's see if we have an optimal solution. Who has something to say about this? Is this solution
That's an
optimal? This is the solution we are getting. Is it
Mm.
optimal?
No.
No, it's not.
No. Why? Why is it not optimal?
Because we
Yes.
still have
There's still a negative value in
negative.
the Z row.
Yeah.
Thank you. So before we move on, we know that once this is not optimal, it means that we have to go to another iteration, right? The next iteration. But let's look at something here. You realize that when we started, I said that the simplex method would be giving you the Z values or the maximum profit or cost at each of the points, the vertices. If you take a picture of the graph that we drew when you were solving the Fan Mill Ghana Limited, I think I have this here. You realize that this is it. You realize that it was bounded by these vertices. And at each point, there was a Z value that we were getting and an X1 and X2 value. Please, do you see it? When you take this, you realize that at the first iteration, we had a Z value of 0. Okay, that was at this point. We'll go back to the Excel again, and then you will see that now the iteration we just did, which is the iteration 1, has given us the optimal solution or the solution for this point A. So you will see that the Z value, we are having the solution of 1000 on our Excel. We are having X2 value of 20 and X1 is 0. Let's go there and see what I'm talking about. So when you come to the Excel, you see that at iteration 1, we are having X2 value to be 20, which was the same at point A on the graph. X2 value is 20. The Z value is 1000. And there is no value for X1. Please, do we see it? So that goes to confirm the point that the simplex method also does the calculation around the points that bound the feasible solution area. So note that. So this is the fact, we've established the fact that this is not optimal. So we have to go ahead. Now, to go ahead, we have to repeat the same process. So who can tell me what to do first?
Question.
Yes, I'm listening.
Please, why is it that with the iteration 1, we left the ratio column empty.
We are now coming there.
Oh, okay.
I told you that before you can do a subsequent iteration, that is when you have to go and find ratios and find pivot column and pivot row and all that. Okay. So when you do it up to this point, you can take the decision, or you can assess whether you have reached optimality. And we said that no, we still have a negative value here. And so we have to move on. So to move on, now we have to now go back like the steps again. You see, that's why we said iteration. We repeat the same steps again. We are going to find our pivot column, find our pivot row, and remember, to find your pivot row, you have to do the ratios first, and then you find your pivot element. So we're going to do that again. So in my case, I'll just copy this and bring it here and name that as iteration 2 and delete the old values from it because we are now going to compute. So what is our new pivot column? What is our new pivot column? Our new pivot column.
S1. S1 column.
S1, thank you. So S1 here becomes our new pivot column. And to find the new pivot row, we have to do our ratios. So what will be the ratio for this row? The X2 row, what will be the ratio? Based on what we did first, what will be the ratio? Who remembers how we found the ratios?
It
Right
was
hand side divided by pivot column value.
Thank you. So what will be the ratio for this?
20 divided by 1.
Thank you. 0.5 divided by 0.5
0.5, yeah.
Yes.
is equal to, and that will be what? That will be, oh, you have the calculators with you. Give me the answers.
40.
Thank you. 40. And then for S2, it's going to be 60 divided by 2.5. And that will be,
24.
come again?
24.
24. Thank you. So which one would be our pivot row now? Which will be our pivot row? What is our pivot row?
24.
0.5 X2.
X2.
The last one.
Did you say X2?
S2. Slab 2. As in
The
slab 2.
minimum
Slab
ratio.
2.
Yes.
Thank you. Someone was confused. I was saying 0.5. 0.5. That
Wait,
Christopher.
No, it's me. Hold on, please.
Yes.
I never wrote this. You said the smallest possible, the smallest positive value.
Ratio
Yes.
value.
Ratio value here.
Yeah, the smallest positive ratio value.
Okay. I didn't add ratio, sorry.
Okay. So we know 24, or that's the smallest. And so S2 is our new pivot row.
Okay.
So now that we found our new pivot row and the pivot column, what is our pivot element?
That is 2.5.
2.5.
Thank you. 2.5. So that is 2.5. Okay. Now that we all understand the process, the first thing, like we said, is to now find the rows, the new values for our pivot row. So we know that this is our pivot row. This is the current values, but we have to find the new values. And remember, we said that because this wasn't optimal, and we identified X1 column to be the pivot column and S2 to be the pivot row, X1 will now come and replace S2 here. So that will be the entering variable, and S2 is leaving. So at iteration 2, we would only have Z, X2, and X1. So this row now becomes a new pivot row that we're going to compute. So how do we compute our new pivot row values? Per the previous one we did. How do we find the values? Volunteer. How do we find the values? Our new pivot row, what was the equation? We wrote it down, right?
Find the pivot element.
Okay.
We divide the current pivot row value by the pivot element.
Thank you. So that means that at this point, we're going to have 2.5 divided by 2.5, right? And that will be 1. We're going to have 0 divided by 2.5, and that will be 0, right? Please find negative 1.5 divided by 2.5 for me. Negative 1.5 divided by 2.5.
Negative
Negative 0.6.
0.6.
Negative 0.6.
Thank you. And then 1 divided by 2.5.
0.4.
And the last one, 60 divided by 2.5.
24.
24. Thank you. So we have our new row value. Now, per the formula that we wrote down, we have to use that formula to find the new values for the other rows. The other rows, which in our case is the X2 and the Z rows. So first of all, let's do for the Z row. The Z row. So we all know it is the current values. The current values, which in this case is the negative 15, 0, 25, 0, and 1,000. Okay, so somebody should do the calculations and then let's go. So we have the current row minus the corresponding pivot column value, which for 0 is negative 15, times this new values we have here. So are we calculating? Are we computing? So be calculating so that when your answer is wrong, you know where you went wrong and then you correct it. So who is done? Who is done? Who is done? Can hear someone punching calculator today?
Okay, Dinah.
Yes, boss.
I have 30, 0, 6, 0, 6, negative 6, 1,036.
Wait.
6 and negative 6. S2 is negative 6.
S2 is negative 6.
6, yeah.
And then the right hand here you have what?
1,036.
Okay. Okay, who else is done? Thank you. Who else is done? We have to compare our results and see if we are. Hello, who else is done?
Okay, sorry, Dana, it's 1,000.
Okay, so I think I have to call names. Prince Kobina. Prince, are you the one who just gave me the answers?
No, it's Francis.
Francis, okay, Francis gave me the answers. Okay,
Yes.
who else? Because we need to compare and confirm our answers.
Quick one, the right hand side is 1,360, not 1,036.
1,360. Okay, and the left-hand side, Francis Aqua.
Yes,
Please, what were your answers?
I'm not computing.
Okay, all right, I'll be waiting. Prince Kobina, please, if you are talking to someone else, kindly mute yourself so that you don't interact, okay? Kwekwahe,
Yeah,
are you done with your answers?
just a minute.
Okay, I'm waiting. Ivy, how far?
Yes, please. I'm on it.
Sure.
I'm on it, please. Sorry.
Okay, David, how far? Where is Miriam? Miriam, are you on it?
Yes, please, I'm on it.
Okay, all right. So let's give ourselves some few minutes. But as soon as you're done, you let me know. Whoever is done should let me know. Because we need to confirm Francis's answers.
Madam
I'm
Dina.
done.
Who is done? Francis Aqua. Francis, are you the one who said you are done?
No.
Oh,
Steven.
who said? Steven.
Yeah.
Okay, so what were your answers?
Okay.
I got 0, 0,
Mm-hmm.
16,360.
Okay, so that was from Steven. Okay, all right. Thank you, Steven. Ivy.
Madam Dina,
Yes.
when you're finding the Z max, what value multiplies the other side?
Okay, so you have the formula. Let's go to the slides and then you get it clear there. Okay. So I know you pick the current values, and then you multiply it with you subtract the product of the corresponding pivot column value. So for instance, if you take this, okay,
Yes,
you are doing this current value, the current values here, okay,
yes,
then you do minus, then you pick its corresponding value, pivot column value. In this case, it was negative 15.
yes.
Then you multiply that negative 15 by the new row, the pivot row that we found. These values.
Okay, so it's we're using negative 15 just as we use 50 in the first one.
Exactly.
And we use 3 in the second one.
Yes.
Okay.
Mm-hmm. Who else is done with the answers so that we compare? Who else? Now we have two different answers, two different sets, even though the solution, the right hand side is the same. I think there are some differences. So I want about 2 more people to come also bring their answers on board. I'm still waiting.
Okay, so Madam Dina.
Yes, Francis.
I have, okay, I have 0, 0, 0, 16, 6, 1,360.
Okay, so you have the same as Steven had. You have the same as Steven had, right? Do you see my screen? You have these answers, right?
Yes.
Okay, thank you. One more person and then we go. One more. Where are my ladies? Miriam. Miriam, are you done? Or you are lost?
Yeah, I'm kind of confused with the process.
Oh, process ni na say answers no.
Yeah, the answers.
The answers. Okay, we'll come back to you. Christabel.
Yes, Dinah.
Yes.
I am on it, but because I don't have a calculator with me, I'm having challenges computing.
Okay, I understand. Working this out with that calculator. So who else? Yes.
Prince.
Yes, Prince. Yes, Prince. Prince, give me your answers.
I have 0,
Okay.
0,
Okay.
16,
Okay.
6,
Okay.
1360.
1360. Okay, so we can see that about 3 people have confirmed this result as against what was earlier given us. So Francis Andolfo, you gave us the earlier one, right?
Yep.
Yes, I think you
Yeah.
should look at the computations again. The correct answer
Okay.
should be 0, 0, 16, 6, and then 1360. Okay. So let's quickly
Okay.
find the S2 row as well.
Oh,
We know we are using the
excuse
same
me.
formula. Yes.
Is it 6 or -6? Can we look at that portion again? I understand the first, the 0, 0.
Okay. So let's go back to, because 3 people confirmed 6. So, okay. Please, do we see the slides? Are you seeing the slides?
Yes,
I'm
yes,
sharing the
yes, we do.
slides. Okay. All right. So I want us to go to that iteration and then look at the computation there.
When Okopo bi no da Okoto. No what's better the premise and sana Okoto.
Okay. This that's computation, right? This one. This one. Okay, so Francis, you want us to look at the last but one. So we have the current row was this minus -15 multiplying these.
Yeah.
Hey, who
That's
is
the
talking?
no, me, ma'am, I'm getting
Prince, mute yourself, Prince.
Thank you. So
They have the part.
Francis.
They are selling it out. Okay.
Hello.
Prince Kobina, can you hear us, please? Are you with us here? Prince Kobina, are you with us? It looks like he's not aware he's unmuted. Okay, let me see if I can mute him.
Hey.
I can mute him too. Hey.
He has muted himself now.
Okay, thank you. So Francis, let's look at this. This is that computation, what we just did.
Madam, why are you calling me?
You were disturbing the class.
Oh, sorry.
So Francis, this is what you requested we look at.
Yeah.
So for that particular value, it will be negative. It will be 0 minus 6. So that's the same as 0 plus 6.
Okay.
So that's how come it's possible.
I think I had negative 0.4 instead of 0.4. That's why I'm sure.
Oh, okay.
Okay. All right.
Okay. So are we all okay up to this point? So we now know how we got this. So let's quickly find the last row. Let's quickly find the S2 row and then see if that iteration will give us our optimal solution.
I have 0.
Okay, you're done.
I have 0.
0.
1. 0.8.
0.8.
Minus 0.2. 0.2 minus 0.2.
I can't hear your voice seems far away. Is that 0.8?
Minus 0.2.
0.2. Okay. And then
8.
And then 8. Okay, so let's wait for the others to confirm this
ready.
for us. Okay. Do you have the
Is that-
same?
Yeah, I have the same.
Thank you. Who else? Who else? Who else has the same? So that we are sure. Then we move on. Abigail, Abigail, tell her I'm in class. Who else has the same, please? Any other person to confirm our answer for us?
Okay, so
Mhm.
I think it's the same. 0, 1, 0.8, negative 0.28.
Okay, okay, okay. So we have 0, 1, negative 0.8, negative 0.2, and 8, and that is our answer. So have we reached optimality? Have we? Do we have an optimal solution?
Yes.
Yes.
David. 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 Is David here with us? Hello, David. Okay, Judah. Judah. Judah Jabin. Okay, locked in but not here. Ivy.
I'm here. Oh, I'm here.
Okay,
No,
Ivy.
I'm here.
I-
My
I'm
background
a bit,
is very nice.
I'm a bit lost, but like I said, I'll follow through with when you send the recording.
Okay, okay, that's fine.
Yes. But I
David.
got it to the okay. Sorry.
Yeah, so I'll send the recording and then the slides as well, so that you take your time and go through it. Okay. I wanted to
Thank you.
find out from David and Judah.
Dan, I'm here. Oh, I'm here.
Yeah, but Judah, you've not been talking, you've not been contributing. Did you
No, I
get
have.
the answer?
No, please, I didn't.
You didn't?
No, I didn't.
Wow.
So I'm following Ivy. I'm also waiting for the recording and then we'll
Hey.
step you with questions later.
I got, sorry, Madam Dinah.
Yes, Ivy.
I got it to the iteration 1. I got how we got the Z max in iteration 2. But I'm just lost with getting the calculation for X2 in iteration 2.
Oh, okay.
Are we
Okay.
repeating the same step as we did with
The same
the
steps.
Z max?
Yes, the same formula. Yes,
Okay.
the same formula. Okay.
Okay.
Yes, the same
Okay.
formula.
Okay.
Yes. Christabel.
Auntie Dinah.
Yeah, have we reached optimality?
Yes, please.
Why do you say so?
Because we don't have any negative values.
Okay, in the 0. Okay.
Yes.
So this tells us that we have reached optimality. So we can pick the right-hand side values to represent our optimal solution. Yes, Ivy.
Well, I thought we reach optimal value when there's no negative sign.
Yes. And that's why we are saying that, yes, we are there. Because when you look at the Z values, there is no negative value here. And so we can confidently say that this solution here, where I have highlighted, is our optimal solution.
Yes,
so
yes.
you realize that we have the value for X1, we have the value for X2, and then we have the Z value at that point. Do you remember that this is the same thing we had when we used the graphical and the Excel?
Yes.
When we solved the Fan Mill Ghana Limited, we had X1 to be 24, X2 to be 8, and then the maximum profit was 1,360. So you realize that with just these 3 iterations, we have been able to solve that fan mail Ghana Limited without drawing graphs and calculating and doing ISO cost and all those long processes. So like I said, this one looks complex, but it is very simple when you follow the steps. When you follow the steps, you pick the formula for getting the new rows. You are able to identify your pivot column and pivot rows. You get your pivot element right. You use the formula and then you calculate well. You can use some few minutes to solve a particular question on using the simplex method than you would even use the graphical method to do. Please, any question up to this point? For those of us who got
Okay,
lost,
so
I believe,
all right. So first question.
Yes.
Will you be required as to the approach to use?
Yes. Yes, as in if a question is given, whether you will be required to use the simplex, the graphical, yes. Yes. The only method you will not be asked in exam is the sensitivity, because you will not take an Excel there. And so for sensitivity, the results will be given to you, and then you interpret or you answer questions based on the results. But for the graphical and the simplex, you'll be asked to.
Okay, so I think most importantly, that quite make our assignment easier, because with assignment, I think that we will be required to, if you are using the graphical method, you would have to sketch a graph.
Yes.
And I learned you have to present everything, you have to type everything. So if you are going to use the graphical method, it will mean that you have to sketch a graph.
Yes.
Yes. So that in the assignment, it wasn't specified as in which method you should use. So does it mean that we can go ahead now that we know simplex method?
Really? Are you sure it wasn't specified?
As it was specified.
Oh, okay.
Because
All of
I
them.
think I saw, yeah, I think I've seen your assignments and all of them.
I think it's two simplex, one graphical or something.
Oh, really? You already have a question on simplex?
I would have to.
Yes.
I would have to confirm that.
Okay.
But then, Madam Dinah.
Yes.
So if we are going to sketch, right? And you have to do that. We have to do that using a computer. I mean, so we have to do it to scale, or what do we do?
You're doing that in Excel. You can do that easily in Excel.
Yeah, so to scale.
Oh, not drawn to
Francis,
scale.
Excel does it to scale.
Even that, you're usually not required to, draw it to scale, because, you can actually get the correct one when you're using the graph.
Okay.
Yes. And that is why we go ahead to do all those computations to even find the coordinate at each point and all that. Okay. So yours is to get the graph drawn with all the constraints, the demarcations, the feasible solution area and all that. And then you do the calculations to get your answers.
Okay. So now we know our Z max and then the X1, X2. Now, if you are asked to determine whether there is slack, does it mean you have to plug them in the equations and determine?
Plot them in your equation. Are you talking about what we are doing today, or you're talking about the assignment?
What we are doing today. In case what we are doing today, you are asked to calculate slack.
Oh, yeah. So now that you have your solution, you know that once you have the values for X1 and X2, getting your slacks isn't a problem again. Do you know that? Okay, let's go to our screen, whiteboard. Okay, because we have formula there already. So So you have this. So you have this, okay? This is the standardized form, okay? If you have this equation, and then you have the values for x1, x2, yours is to input that into those equations, and then you'll be able to find s1 and s2. Francis, do you get me?
Yeah, I get it. I get it.
Because-
But I thought since we are using the simplest method, all these the S1, S2 will be evident on the table. That is why I asked the question.
Oh, okay. I get you. But even that, you still have to, in case you are asked, okay, in case you are asked, I'm sure that all you have to do is to just input the x1, x2 values into the original equation that was given you, and then you derive x1 and s1 and s2 values, and that's all.
Okay. Thank you.
You're welcome. Please, any other question up to this point? Any other question? Any other question? Any other question?
No question.
Okay, so it means that based on what we have done today, if you are given a question that has 3 variables, decision variables, or 4 decision variables, we can still use the same approach to solve them.
Yes.
Now, per this approach, okay, one thing you should also notice is that this is what we have done today is the maximization problem. But if you are solving a minimization problem, it's quite different. When you are solving a minimization problem, it's quite different. Have we come across or have we been introduced to duality, or have we heard anything about duality? How to change an LP problem into its dual?
No, please.
Okay, so let's use the rest of the minutes to quickly go into that. You know, when you check the slides that I'll send to you, you realize that this process that we did today is for maximization. But if you are given the problem and it is in a minimization, it's a minimization problem, you first have to convert it to maximization problem before you then go into the steps like we did today. So you first change it from minimization to maximization before you come and now write your standard form, do the conversions and all that. Then you start with your Tableau. Okay, so let's quickly look at how to change the problem from the minimization to the maximization problem. And then once you get it changed, you will use the same procedure that we used today to get your solution. Okay. Now we say that in linear programming problem, every primal problem has its dual problem. What are we saying? Every minimization problem has its maximization problem, and every maximization problem has its minimization problem. All you have to do is to now just do the conversions. So how do we mean? I did something on this Excel. I don't know if it will help us. Let me show it. Maybe that will help us to understand it. So if you look at this Excel, I tried to write something here because we are not physically in the class, at least to help me explain. So let's say that you have been given this minimization problem to solve using the simplex method. And we say that you have to convert it to a maximization problem. How do you do that? There are 4 things that changes when you are converting a problem from the primal to its dual. So it could either be from maximization as its primal to the dual as its to minimization under the dual, or the primal can be minimization problem like we see here, and you are asked to change it into maximization. That would be the dual version. Okay. So what are some of the things that will change? If you look at this problem, you realize that we have 3x1 plus 5x2. Look at the position of the values, okay? And then we have the constraints. x1 is greater or equal to 4. 2x2 is greater or equal to 12. 3x1 plus 2x2 is greater or equal to 18. Now, if you're asked to change it to the dual, the objective function coefficients, they change positions with the right-hand side of the constraints. That is the first thing that changes. So you may want to jot it down. The objective function coefficient swaps position with the right-hand side of the constraints in duality. That is the first change, one of the changes that takes place. Now, what again changes? So you realize that when you take the primal that we have here and you compare it to the dual here.
Please, Madam Nina.
Yes.
Please, can you make that statement again?
Okay, so I am saying that if you take the changes that take place, the first change is that the objective function coefficients, okay, they swap positions with the right-hand side of the constraints, these ones. So the figures here, the objective function coefficients, will now move to the right-hand side of the constraints, and the values on the right-hand side of the constraints will move to the coefficient position. If you look at it at the dual here, you see it's displayed here. It was a minimization problem here. Now we are having a maximization problem. However, the right-hand side coefficients are now here. They are now replacing the objective function coefficients. And what used to be the objective function coefficients have now moved to the right-hand side of the constraints. Okay, that is one point. Please, have we all gotten that point? That is the first change. Then the second change is that the x's will change to y's. The x's, so you realize that in the primal, we have x1, x2 running through the model. But if you compare it to the dual, you see the y1, y2, y3 running through the dual. We'll look at it. That is the other change. So the x's, we know the x's in our original value or in our Farm Ghana Limited, the x's are the quantity of something to produce and all that. It will change to now prices. Y's, the y's are representing the prices of their respective resources. Now, the third thing that will change is that if it is a minimization problem, it will change to a maximization problem. And if it is a maximization problem, it will change to a minimization problem. The signs in the constraint will also change. So you see that in the primal, we have greater or equal to, greater than or equal to, greater than or equal to. And when it comes to the dual, the sign also changes. That should be less than or equal to, because the sign changes. The sign changes. The last thing is that the decision variables also changes places with the constraints. So for instance, you realize that in our Fan Mill Ghana Limited, we would have labor constraints and we'll have milk constraints, okay? But when you change it to its dual, the constraints or the resources are now being captured in the objective function. And so you are now going to have the decision variables, which were the fan yogo and the fan choco, now being captured as the constraints.
Yeah, hello.
Dinah.
Yes.
Please, did you say the decision variable also changes place with the constraints?
Yes.
Okay.
All right. So,
No, madam, we cannot see the dual formulation well. Can you shift that?
Oh, really?
Yes.
As in, you can see part of it.
Yes, we can see part of it.
Should I make
It's
it
not clear.
smaller? Is it okay now?
Yes, it's okay. Thank you.
Okay. Yeah, so
all right.
someone was.
So, yeah, I was the duality constraint. Yeah, you have X, Y1, which I understand. Where from the 3, Y3?
Okay. So you see that I wanted you to write the changes first. Have you captured all that?
Yes.
Okay. So you see that per this Excel, I have the primal here. I have this picture, which has, has been rotated. And then I have this. What it means is that now you see, when you take the constraints here, there are 3 constraints. So we'll say that the first constraint is Y1. The second constraint, Y2. The third constraint, Y3. Okay. In the initial, we would say that those are resources constraints. Let's say time, space, what else? What
Labor.
else? Labor. So these are resources. Okay. These are resources. So we are looking at the prices of the resources. And so Y1 will represent the time, Y2 will represent space, Y3 will represent labor. Now yours is to change the position of this model. So you realize that I took a picture of it and then I rotated it, is it 90 degrees? Yes.
Yeah.
90 degrees to the left. Okay. So you realize that the right-hand side is now at the top, which I converted into my objective function coefficients. So you're now going to have 4y1, because we said this one will carry y1. This will carry y2, and this will carry y3. And remember, the y's are the prices of the resources. The prices of the resources. The prices of the resources. And so if these resources are moving to the objective function, it moves with its prices. So we're going to have 4y1 plus 12y2, you see here, plus 18y3. That is what comes here. Now, subject to, look at this, the position. I wish I was in the class so that we
Nina, please, I think you should write it on the whiteboard so that we are able to see and identify, because confusion in one.
Confusion. Okay. So we have, okay, then let me copy. Hey, I can't copy it to the whiteboard. Let's go there and write. Let's go to the whiteboard and use our fan mail gun. Okay. Okay, so let's say, was anybody, did anybody write the formula for me? The model, what we were using for the changes. Okay, so please help me write it here.
3x1 plus 5x2 subject to x1.
3x1 plus 5x2.
5x2.
I'm not able to
Subject
write too
to.
well this with this. Subject to
x1 is greater or equal to 4.
x1 is greater or equal to 4. Okay.
2x2 is greater or equal to 12.
2x2 is greater or equal to 12.
3x1 plus 2x2 is greater or equal to 18.
Okay, 3x1 plus 2x2.
Yeah.
Is greater or equal to 18.
Yeah.
Okay. And then our non-negativity, right?
Yeah, I think so.
Okay, thank you. So we are saying that the right-hand side of the constraints would swap position with the objective function coefficients. That was the first change we wrote, right? Remember, this is a minimization problem. So the dual is going to be a maximization problem. Okay. So we said that those values here will change position with those coefficients. And we said that those values, instead of now carrying x1, x2, x3 in the objective function, will now carry y1, y2, y3. And so we're going to have 4y1, okay, plus,
Nina, please,
yes.
before you proceed, since the primal has just x values, s1, s2, are we going to say we are going to let y represent something before we introduce it in the dual?
As in whether you have to define the decision variables.
Yes.
Yes, you can. And we said that the y's are representing the prices. So for instance, if per the example we gave, if this is time, this is space, this is labor, then we'll say that y1 be the price of time, y2, okay, be the price of time, or y2 be the price of space, and y3 will be the price of labor. Yes, the unit price of labor. Okay, so we said that with that understood, we said that because this is changing position, this side is changing position with the objective function coefficient. Okay, we are going to have 4y1 plus 12y2, okay, plus 18y3. Now this will become our objective function. Okay, and then this objective function here will now become the right-hand side of this problem. So let's go and write that one there. So the right-hand side, we know we are going to have only two. That will be 3 and then 5. Please, are we clear up to this point? I want us to take the changes step by step. So which means that automatically our constraints are going to be just 2. Do you see it?
Yes.
Yes. So now that we have this, let's put our subject to sign here. And now come and write.
So what will happen to the third constraint?
Which third constraint?
Yeah. The x1 equals to.
So you follow it and then you will see. Now we are going to write our constraints. This is how the constraint will be. You take that like this in this order. You add this. This will be one constraint. This will be another constraint.
Okay.
So we're going to have, instead of x1 plus 3x2, what would we have? We said the y's are representing replacing the x's. So looking at the y's here, what would we have? y1 plus 3y3. Please, do you see it? So any x's that you see on this row, you represent them, you replace them with the y's here.
Okay.
So we are going to have, for this constraint, it's going to be y1 plus
3y1.
3y3. Remember, we said we are representing, we are replacing the y's, their respective y's.
Okay.
We're going to have y1 plus 3y3. Let's hold on with the sign and go to the next constraint, which is this one. Remember, we are replacing the x's here with the respective y's. So we are going to have
Y2
2y2 plus 2.
2y3.
Thank you. And that will also form another constraint. Now, the last thing that will happen will be the changes in the sign. The sign. So because it is less than or equal to, this time it will be, no, this is greater than or equal to. So this time it will be less than or equal to. And this will also be less than or equal to. Then our non-negativity will change to y1, comma, y2, comma, y3 is greater than or equal to 0. Instead of x1 here, comma, x2 here, being greater or equal to 0. And we are done. Please, do we see the difference between the primal and the dual?
Yes.
So if you are given the problem like this is how it will change to. Okay, with this understanding, let's quickly change our Fan Mail Ghana Limited, okay, to the primal, to the dual, and let's see if we have really understood why. Let's do that. We have some few minutes to go. So we have Z max, okay, is equal to 40x1 plus 50x2 subject to x1 plus 2x2 is less or equal to 40. And then we have 4x1 plus 3x2 less or equal to 120. Then we have our non-negativity, x1, x2 is greater or equal to 0. So with the understanding, now let's write it in the dual. Remember, once this is maximization, the dual will be a minimization problem. So we're going to have Z-min, right? So who can volunteer to continue for me? Z-min. So this is the primal. So who will volunteer? With the understanding, who would volunteer? And this is the dual. Okay. Who would volunteer?
I try.
Yeah.
Yes,
Okay.
please. I like it when you want to.
Okay, so I have Z main
Okay.
is equal to
Mm-hmm.
40y1
Mm-hmm.
plus 120y2.
Okay. Okay.
Subject to
Mm-hmm.
y1 plus 4y2
Mm-hmm.
greater or equal to 40.
Mm-hmm.
And 2y1 plus 3y2
Mm-hmm.
greater or equal to 50.
Equal to 120.
50.
Mm-hmm.
Then your y1, y2 is greater or equal to 0.
Thank you. Who gave me the answer?
Decline.
Kwekwahe. Thank you very much, Kweku. So that is it. You see, it's not difficult. You can use like 2 minutes or even less to quickly change it before you start with the simplex problem. Please, with the conversion from the primal to the dual, do we have any challenges with that? Do we have any problem? Christabel?
I'm okay with it.
You're okay. Ivy?
Yeah.
I'm okay with it, ma'am. Please,
Wow,
thank
that's
you.
great. Francis Aqua?
I'm fine.
You're fine. That's great. David? Today I'm on David, but I think he's not here with us because anytime I mention the name, he doesn't respond. Francis Andofo?
I did for you.
Thank you. I'm glad you are all able to convert from the primal to the dual. So this is very basic. Once you get it converted into the dual, so for instance, if you are given the problem in minimization, please don't forget the first thing, that is if you are asked to use the simplex method to solve, the first thing you change it to the dual. That is, you change it into a maximization problem. And then you are able to now follow the steps, convert it into the standard, that is by introducing the slacks, equate your z function to 0, use the values to form your initial tableau. Then you continue with the process where we identify the pivot column, you identify the pivot row by using the ratios, then you use it to find whether you have reached optimality. If not, you know how to find optimality. That is, if there is any z value, if the z values are non-negative, then you know you have reached, you have landed. If not, you go to the next iteration and you repeat the same process until you know that I have found optimality. So that is basically it. That is basically Simplex Method for you. But please, I would urge you that based on the understanding, try and solve a 3 decision variable or 4 decision variable question. You can create an LP problem on your own. Okay, 3 variables or 4 variables, and then you try and solve it so that you can sharpen your skills there. So without any question, I think that brings us to the end of.
Please, I have a question.
Okay, cool.
Please wait. So to solve a simplex method question,
yes,
you are first supposed to convert it from its primal to dual before you start with the converting to standard form.
No.
It's in a minimization.
Yes, Kweku, if the problem is given to you in a maximization, you don't have to do any primal dual conversion again.
Okay.
Then you start with the initial process where you change it to the standard. And so the thing is that you should always make sure that it is in maximization before you start the process. So if the question was given to you in a minimization form, then that is when you have to do the conversion first before you start with the process.
Okay. Can I ask a question?
Yes, Francis, go ahead.
Yes. So when you write the objective function in a minimization case, like converting it to the dual. So does it mean the objective function is already equal to 0, or you would have to equate it to 0?
No, you first do the conversion before you now come and write it in the standard form. It is the standard form that you will equate it to 0.
Equate it to 0.
Uh-huh.
All right. So like the case we will have the z minus 40y1 minus 120y2 minus there's 0/1/2. Is that the case?
Please come again. Which example are you using?
Yeah, so I'm talking about the.
Okay, you're using this one.
Duality, yes. So if you convert it to standard form, and then we equate it to 0, we are going to have z minus 40 minus 120 minus 0 plus 1 0 Okay.
Exactly. Yes.
All right.
Yes, that's how it would be.
Okay.
Yeah. Any other question, please? Any other question? Any other question? Please, this one looks simple. Oh, that's why I've advised do a 3 or 4, and then you would know that now you are. Sometimes you can go like 4 iterations before you find your solution, or even 5 before you find your solution. So you have to solve more questions.
Okay, so I want to understand why you would have to convert it. Does it mean that if it's minimization and you go ahead and use the simplest method?
Yes, per the approach that we use, you realize that when you go onto YouTube and then you type the Simplex method, people have different approaches, okay, of solving it. But per the approach that we are going by, the problem should be in a maximization form before you solve it, okay. When I give you the slides, you will see all those things in there.
Okay.
So it has to be in the maximization. That is why we do the conversion. But if in an exam it is given to you in a maximization, then bingo, you don't have to do any conversion. All you have to do is to start with.
Okay.
Yeah.
A question.
Yes, boss.
Please, after getting your optimal solution, are you going to convert it back into the minimization to interpret the results?
Oh, okay. Wow, that's a very great question. I almost forgot to talk about that. So let's go back to the slides. It's in there though. Please tell me if you can see the slides instead of the.
Yeah.
Okay. All right. So it is written in there. The answer, for instance, this example that was given, it was given in a minimization like this one. This is a minimization problem. And so we first had to convert it to the dual, and then we converted it to this max. So they solved it. The step-by-step process wasn't shown in the slides, but you can go through it and then solve it on your own. This was the solution, but it was indicated that you cannot pick this as the solution. Unlike the maximum one, the maximization one, you remember that we picked the right-hand side values as our optimal solutions. Okay, but this one, you will pick those values, the x1 and x2 values at the top. And then the right-hand side will always be the same. So please follow the slides to solve more examples so that you get through with those ones. So you don't pick the right-hand side if you do the conversion. You pick the S1 and X2 values and then the Z. This is the same as the Z, remember. This is minimization, so they usually represent it with a W, but it is the same as the Z values that we did, like this. So instead of W, we use Z, that is the same thing. Okay, so instead of picking 42 for the Z, 3 for Y, and then 2.5 for the Y2, you have to pick the X1 and X2 values instead.
Okay. Thank you.
Okay. All right, I think our time is up. Any other question? Are we okay? I think solving of more questions will help us, so let's do that. But in case we are solving any questions and we have challenges, please bring it on board so that we all discuss and then we all learn from there. That's how the operations class works. You do things together. And then
I hope we can bring the assignments if we don't understand.
The assignment. Is it a group work or individual?
In case we don't understand it, can we bring it to the group?
Oh, you can always meet as a group to discuss your works. You do know that you can always do that. You meet as a group, you discuss the work, but it's an individual presentation. So at the end of the day, you go and type, you go and do your work, but you meet first as a group, discuss the work, get the understanding, get how to solve it, and then you go and present it separately. I think that one there is no copy. It's
no,
a discussion.
it's group work.
Exactly, group work. You meet, you discuss, okay, where you don't, because the formulation alone can take one person like the whole day. But if you meet as a group and then you are able to formulate the model, you are able to solve easily and then you move on. So please don't work in isolation. That's all I will say. Don't
Okay,
work in
thank you.
isolation. You're welcome. You're welcome.
Kweku, are you hearing?
Okay, all right. So thank you all for your time. I hope to come to class one of these days.
Yes, you have to.
Yes. Remember me when you pray, okay?
Sure,
I'll
sure.
see you soon.
Yeah.
Hey, hello, Lina.
Hi, Francis.
Yeah, so you said you will remind Finish on the
Yes, about the
profit.
ISO cost, yes.
Yes.
The ISO cost and the ISO profit is very, very key. Very, very key, especially it has to help you understand it. I don't know if you're okay with the LP, the irregular LPs.
Yes, I'm okay.
You are okay.
Yes.
Then it means you understand the ISO profit.
No,
Because if you don't know how the ISO profits, because if you don't know how the ISO profit works, then how did you identify the multiple optimal type of irregular, the irregular type, the multiple optimal type? Because it is the ISO profit that will help you determine it. I don't know if you get me, Francis.
Yes, I do.
So how did you understand that without understanding the ISO?
Yeah, so we have to, with what we did, the multiple, we would have to determine the Z values.
Okay.
And then, yeah, we have to determine, as in work it out. But
okay, for all the points.
Yeah, exactly, for all the points.
Okay.
That's how we.
That is good. That is one way you can identify it. But trust me, most of the time, Doc sets those questions as IA questions. And IA questions, you're using like less than 2 minutes to identify if a problem is an infeasible type or a multiple optimal solution type or an unbounded type. Okay, so it is this ISO profit line that helps you to easily identify, because it is when the ISO profit line relies on exactly one of the constraints, then you know that you're going to have multiple solutions. So I'll discuss with Benes. And then
okay, then I'm here.
Yes, Benes. So the ISO profits, Wahala.
On that day, Doc said we shouldn't talk about the ISO profit and then the ISO cost line, because most of the times, like, students get confused when the concept is introduced. So we use other features to help them identify the irregular types.
Okay.
So in the main class, the focus was not on the ISO profit and then the ISO cost, but rather other features. So I discussed with them that we'll make time, and then during a tutorial section, I can take them through that. With that one, our focus will only be on the ISO profit and then the ISO cost.
Okay.
So that they can use that feature also to help them determine the type of irregular they are dealing with.
Yes. So I think that's what they are requesting.
Yeah, an instruction don't give that, because the concept is a lot and the irregular types are also many. We should do away with that feature.
Okay.
Yeah, that is why I didn't talk about it. Yes.
Okay, but we will still take them anyway.
Yeah, course rep can make a time, schedule a time, and then I'll take them through.
Okay, so course rep, over to you. Who is the course rep?
Mr. Kweku.
Kweku Ahin. Okay, so Kweku Ahin, over to you. Okay, because you need
we
it.
have a class, so I'm logging out.
Okay, Benes, thank you, Benes. Thank you. So Kweku, over to you, because I remember our time, it was he listed some, he just brought the the models like that. And then he will ask you to identify which type of irregular programming problems they each one of them, you know, is. And you're going to calculate for all the points with delay, but you can easily use the ISO profit. So like he has said, please make time, and then let's get that one sorted for you. Okay.
Sure.
All right. So thank you all for your time.
Just one more question. Do you have any idea when IAs will be written? Because we still need to have the academic calendar.
Which week are you now?
3.
Oh, okay. Usually it's between week 7 and 10. So it's based on the lecturers when they want to. So some will do it week 8, week 9, week 10. But it depends on the lecturer. But Doc will always give you prior notice. So
okay.
Yes, and then he will tell you which topics or which areas the IA will cover.
Okay. That's it. Thank you very much.
You're welcome. Okay, all right. So have a nice day and catch you on Monday.
All right.
Bye.
All right. Thank you, Diana.